Welcome to the video of paragraph 10, in which we'll be discussing blood groups. So in today's video we will learn about the blood groups, more particularly about the antigens, which decide which blood group you have, the antibodies, which make everything very difficult in this paragraph, but no worries, blood donation, which is something we'll discuss in a second, and the rhesus factor. So we all know the red blood cell, the beautiful donut-shaped cell, as we see in the picture right here. Now, in the different blood groups, it's nothing more than the two antigens, antigen A and antigen B, which might or might not be on the surface of the red blood cell. Just like our pathogen, and most cells actually are covered with antigens, our red blood cell is as well. So we have 4 blood groups: A, B, AB, and 0, which is often called O. Now, the difference between these blood groups is just whether antigen A is present, antigen B is present, or maybe both antigens, or neither. And the antibodies which are coupled to that. So let's start with blood group A. In this case, blood group A will have antigen A on the cell surface. So in this picture, it's the green triangle things which are antigen A. In the plasma of someone with blood group A, you will find antibodies, but not A, antibodies B. Because if it were antibody A, that would mean antibody A and B would match, and then the antibodies would cover the antigen, as you can see in this picture. This is what we've done in the past. The antigens of the pathogen would be covered with antibodies, which was great for a pathogen, because in this case the pathogen wouldn't be able to infect cells anymore. It would be big and clunky, so other phagocytes could do phagocytosis on it more easily. But we don't want our red blood cells covered in antibodies. So we don't want a matching antibody. Our body does not need to fight off our own red blood cells. If it would be covered in antibodies, the red blood cell would not have the nice donut shape anymore, but would be big and clunky. And then if it would be passing narrow capillaries, you would risk a blood clot, which is not a great thing for a blood flow. So we don't want a matching antibody. So let's go. So we all know the red blood cell, the beautiful donut-shaped cell, as we see in the picture right here. Now, so in today's video we will learn about the blood groups, more particularly about the antigens, which decide which blood group you. So let's start with blood group A. In this case, blood group A will have antigen A on the cell surface. Now for blood group AB, guess what it has? Which antigens it has? Antigen A and B. So it just has both. Now, because we don't want any clotting, that means it can have neither antibodies. Blood group 0, or some of you will call it O, blood group 0 has no antigens. It shows the sticks here, but it has no antigens, which means it can have antibody A and antibody B. It will cause no clotting. So very quickly, in a nutshell, these are all the blood groups. So antigen A for blood group A, antigen B for blood group B, antigen AB for blood group AB. Just keep in mind, if the antigen is present, we don't want a matching antibody because we don't want our blood to clot when we want it to flow. In some cases we want blood to clot, but that's a different process. In general, we don't want blood to clot. If it goes too quickly, I would say rewind and listen to it again, because in the blood donation part, we are actually taking it one step further. So, in a very different depiction, but actually the same information, are blood types. So you have blood group A with the antigens, which are pink in this time. A is pink, B is blue. The antibody is blue if it's for B, and the antibody is pink if it's for A. And the antigens are pink if it's for A. You get it. So A has antigen A and antibody B, etc. No antigens. It shows the sticks here, but it has no antigens, which means it can have no, it's no problem. However, when it comes into the bloodstream of blood group B, the antibodies A will pick up the blood cell of A. So that would cause. So very quickly, in a nutshell, these are all the blood groups. Blood group 0 so in a very different depiction, but no antigens. It shows the sticks here, but it has no antigens, which means it can have no, it's no problem. So very quickly, in blood group 0, the antibodies, and so on. So A and B are comparable, they just cannot give to their counterpart. Now AB has both antigens, so it cannot give to A because A has the blue antibody. It cannot give to B because it has the pink antibody. It can give to AB because it has no antibodies. And 0 again is a very sad blood group because it can't seem to get from anybody yet. And then finally 0. It has no antigens on the cell surface, no antigens that will respond to the antibody. So 0 can give more. So AB, no problem, and also to the other 0, no problem. So this was really quickly a mix and match. When making this in a test, when studying for this, just very simply think back. Okay, I'm talking about blood group A, which means there are antigen A on it, which means the opposite letter, meaning B, will be the antibody, because if it's a match, it will clot. I know it's confusing, but just take step by step and think it through. And also when doing the donation part, take step by step. Okay, so this antigen will be present, antibodies are not given, so only the receiver, the antibodies matter. Let's look at the whole schedule though. Antibodies, but not A, antibodies B. Because if it were antibody A, that would mean it can't seem to get from anybody yet. Usually people do not have the antibodies for the rhesus factor. So even if you're rhesus negative, so you don't have the antigen, usually people will not carry the antibodies. If you're rhesus positive, so that you have the antigen, you'll never ever ever have the antibodies, because that means they would link up and then you would have blood clots, which is not nice. But rhesus negative people will also not have the antibodies, except, and this is where we like making difficult test questions. Oh yeah, and blood donation, of course people take this into consideration, because we know what happens when your body spots a stranger danger antigen. Then the story of the phagocytes starts happening and they start making antibodies. But so with blood transfusion, of course you're not going to give somebody else who is rhesus negative, you're not going to give it positive blood. But for giving birth, this is where the rhesus factor is a danger. So here we see multiple red blood cells which are negative, so which don't have the rhesus antigen, and are positive, which do have the rhesus antigen. Now the story starts to get exciting when a mother who has one of the upper red blood cells, the negative ones, and who is carrying a child which has the antigens, it's no problem up until the point that the mother starts giving birth. And birth can be quite a gruesome process. Blood is lost, some tearing of the tissues might happen, and what could happen is that the placenta, which mother and baby share, tears. And in this case, the positive red blood cells come into the mother's bloodstream. And we all know, hopefully we all know by now, what happens when a strange antigen, because our body does not recognize it, enters our bloodstream. There is this phagocyte which sees it as a danger, which sees it as a foreign body. So it starts doing what it does best. It starts phagocytosis and the process of activating a cell, making B and T cells to fight off this oh so very dangerous red blood cell of the baby, because it has this strange rhesus factor. So now mother has antibodies against the rhesus factor, which is no problem for her because she's rhesus negative. Baby by now is long out of her body, so also no problem. But it starts becoming a problem when mother decides to have a second child. And that second child could also be rhesus positive. Now mother's antibodies, because the baby is carried within the womb, starts attacking the baby's red blood cells. And you can imagine, as we try to prevent the whole time, we don't want our red blood cells being attacked by antibodies. So this could have gruesome results for the baby, like red blood cell, death is a very plausible result. So usually there are ways to prevent it. They can make inhibitors for antibodies, but usually they are just extra careful around these pregnancies. But in short,